All right, in this video, we're going to walk through how to solve that first practice problem from our Desmos exploration activity. And so in this particular problem, we were given, and I'm going to switch to black really quick, we were given that we have an angle that measures 13 Swifties. And if you're remember, Swifties is just a sort of made-up unit of measure. There are 29 of them within a full rotation of a circle. And so we are then asked to take this particular angle measure and do a few things with it. So the first question is, what percentage of the circumference would this angle cut off? And so if we want to figure out the percentage, we need to figure out what fraction of our circle we're sort of taking up. And so we have 13 Swifties out of a total rotation of 29. And so we have 13/29ths of the circumference of the circle cut subtended. Friends, and so if I want to turn that into a percent, you would just go 13 divided by 29, and I get a decimal. Turn it into a percent. Oops, not multiplying by 100 there. It's times 100 to get us as a percent. And so we would have about 44.8% of a circle is, the circumference is subtended. Now, we can then sort of use this percentage to sketch a picture of what this angle would look like. So what I'd like to do is, I find it helpful. I'm actually going to draw a circle for myself. So I have my circle here. And the reason I like to draw the circle is if we're sort of thinking about this, I can sort of split my circle in half here. And this right here would be 50%. Well, we have a little less than 50%. Now keep in mind up here, that would be about 25% of the circle, because we always start when we draw our angles, and we're going to sort of start from that 3 o'clock position there. So there's our initial ray. And 44.8%, we're going to be closer to 50 than we are 25, not quite at 50%. Halfway between those two would be, like 30 something. So we're going to be probably we're going to sort of make it over there. And here's the thing about a sketch. It's a sketch. It doesn't need to be perfect, but it's to sort of give you a sense of, where that angle falls within that circle. I like sort of seeing it. It gives me sort of a visualization about what's going on. All right, so that was the second question, was to draw a picture. The third one, we're going to convert this angle into a new unit of measure. So we have 13 Swifties, and we want to figure out what that measure would be in Trekkies. So there's two different ways to approach this problem. One option is to sort of create a proportion. So we have 13 out of 29 when it comes to the Swifties. And so we want to know what that would be when it comes to Trekkies. And if you remember, there are 189 Trekkies. So 189. And if this, because we're thinking proportional reasoning, these percentages of a circle need to remain equivalent. So what the number of Trekkies would get us a fraction equal to 13/29. Okay, well, if I wanted to solve this, I basically need to undo my division over here, and I can multiply by 189. And so going over here then, 13/29 times 189, and I would end up with 84.72 Trekkies. So as I said, there were two different ways we could approach this problem. The other option is to use the percentage we found up here in number 1. We know that this angle cuts off 44.8% of a circle, which we found by doing 13/29. So, if I basically need 44.8% of my 189 Trekkies, which would be a total rotation around. And so if you think about that mathematically, that's really just doing 13/29 of, because that's where we got that 44.8% of 189. This expression right here, using that percent of my circle times my total rotation, is the same thing I did up here when I solved my proportion. You know, it's interesting how things like that work out. Okay, so that was question 3, was how many Trekkies are cut off by the angle. And we had one more part to this problem. And we were told, okay, let's get a little more precise here. And so I'm going to go up here into my space right here. We're told that this circle actually has a radius of 5.43 centimeters. And we want to actually find our arc length right here, this length along the arc. So remember, arc length is a part of our total circumference. So in this case, we are going to need to know the circumference of our circle. And circumference we can find by doing 2 pi times our radius length. And so our circumference is about, if we go over here, 2 pi times 5.43. And notice I am using the pi button, and you should find the pi button and use that on your calculator as well. So our total circumference is 34.118 centimeters, and we want 44.8% of that. So just like we did with the, almost the same thought process we were using to find the Trekkie measures, we can use to find our arc length measure. Okay, so we want, 13/29 of that total circumference. And notice, yes, in my work, I have rounded numbers, but I'm actually going to go over here and, I'm going to say, okay, this is A. And so I want 13 divided by 29ths, and then I'll times that by my exact, circumference value that I had in my calculator. And so this is going to get me, and I'm going to use variable S for arc length, 15.29 centimeters. It's a little less than half, which makes sense because if you look at our picture, that arc is less than half of a circle length. Arc lengths do have a unit. They're a length measure, so that's why we want to make sure we include that label of centimeters. Hopefully this helps you better understand how to approach this problem if you were stuck or not sure. Also, it gives you a quick check if you did it right.